Everyone, I'm Mr. Alvin from ACES Math, and today I'll be guiding you through the parametric equations question posted. Now, this is a crucial period of the time of the year, and if you are having difficulty with your content or time management, feel free to reach out to us for consultation and advice, alright? Otherwise, we are all set and let's begin now. So this question is a question on parametric equations, which broadly speaking means when x and y are functions defined in terms of a third independent variable, usually denoted as t, interpreting as time in your context. Okay. Now, as long as you stick to basics, this topic is not a difficult topic at all, as I will illustrate with this example today. So the first part of this question is to construct and prove the gradient of the tangent line at any point in time along the curve is given to be the expression given right here. So to answer such questions, right, is to make use of the chain rule expression that you have been exposed to since secondary school days. And from there, you need to differentiate x and y individually with respect to t. So dx by dt is given to be 2t plus 4. And dy by dt is given to be 3t squared plus 2t. Putting them together and using this expression, you thus have dy by dx is given to be 3t squared plus 2t over 2t plus 4. And there you go. This is the expression for dy dx of the parametric equations given as in the question. Now, the second half of this question is to evaluate the values of the parameter and the corresponding equations of the tangent line when the tangent lines are vertical and horizontal respectively. To answer such questions, right, you always have to ask yourself by going back to basics, what is the gradient and form of a typical vertical line? And the answer to that question, right, has been taught to you since secondary school days or so. For a vertical line, its gradient is actually undefined. And for its form, right, it's actually known to be x is equals to c. So how do we actually evaluate the gradient when it's undefined? Is to look at this expression here and let the denominator be equals to 0. So we will have 2t plus 4 is equals to 0. T is equals to negative 2. So this is the parameter or the time when the tangent line is a vertical line or the gradient of the curve is undefined. So at t is equal to negative 2, x is actually equals to negative 2 squared plus 4 negative 2, giving you negative 4. We do not need to substitute the corresponding value of t at negative 2 into y because the function, the form of a vertical line is simply in terms of x only. So this is it. This vertical line x is equal to negative 4 is a tangent line to the curve when the gradient is undefined. So moving on to the last half of this question, what is the gradient and form of a horizontal line then? Again, the answers have been taught to you since secondary school days. For a horizontal line, gradient is equals to 0, and the form of a horizontal line is y is equals to d. Okay, so when is the gradient function equals to 0 is to equate the numerator of dy by dx to be equals to 0. So we thus have 3t squared plus 2t is equals to 0, and t is thus equals to 0 or negative 2 over 3. Please factorize t instead of dividing by t, if not you will lose one solution. Okay, so we have two moments in time when the gradient is actually 0 or the tangent line is a horizontal line. So separating this, excuse me, at t is equals to 0, y is equals to 0. At t is equals to negative 2 over 3, y is actually equals to 4 over 27. Pardon my handwriting. And there we go. We do not need to evaluate the corresponding x values because a horizontal line is defined solely in terms of y. So these are the two moments when the tangent line is horizontal and the corresponding expressions of y is equal to 0 and y equals to 4 over 27 are the equations of the tangent lines. Alright guys, that's all from me today. If you found this session helpful, be sure to share with your friends and follow us for more. I see you all next time. Goodbye.